Hello everyone, welcome back to the AWS Cloud Engineer Essential series. My name is Dheeraj and today we will explore Amazon API Gateway, the front door to your application on AWS Cloud. Today you will learn what API Gateway is, how it works behind the scenes, and how it connects clients to backends like Lambda or EC2 instances. We will also cover pricing, integration, authentication, deployments, and best practices. Everything you need to confidently design and manage APIs on AWS Cloud. So let's get started. So let's start by understanding what Amazon API Gateway is. Think of API Gateway as a front door to your application. So this is your API gateway. Suppose this is your front door to your application. So it's a service that receives HTTP requests from clients and route them to the right backend service. So over here you can see it's not only the HTTP request that you can get. You can get different types of API request. It can be connected users or your streaming dashboard, web or mobile application. So these all kinds of API request can come to API gateway. This is going to be a front door, and once the request come, then based on your request it can decide to which specific service it has to go ahead, that is the backend service, and route your request. Do you want to reach to CloudWatch? You want to reach to you want to reach to Lambda, Kinesis, other AWS services, or EC2? There are multiple services which API gateway can route you to. While routing that, it can also go ahead and uh, maintain the invocation logs that is there as part of CloudWatch. It can also cache some data onto API gateway cache. So there are a lot of things which happens by using this front door, which makes your experience seamless. And as it is fully managed AWS service, meaning you don't have to manage any servers. So it automatically scales and is highly available, and it can handle all the infrastructure behind the scenes. API Gateway lets you create different types of APIs. One is REST APIs, second is HTTP APIs, and WebSocket APIs. So in this tutorial, we will focus on REST APIs, which are the most commonly used type. You can think of it as a middleware. It sits between your client and the backend services like AWS Lambda or so this is your middleware. It is sitting between your client and your backend service. So uh, common use cases includes mobile application and backend, as you see on the left hand side, microservices, server web application, and third party API integrations too. So in short, API gateway is the perfect way to expose your application's functionality to the world in a secure, scalable, and serverless way. Now let's understand how API Gateway actually works behind the scene. When a client comes and uh, like a web app or a mobile app, as I showed you in my previous diagram, it is going to make a request by using, and that request can be a get request, post request, put request, or a delete request. So this request is sent to API Gateway endpoint URL. Next, the API Gateway validates the request. It checks for things like authentication, authorization, headers, and parameters to ensure the request is valid and from a secure source. Once it is validated, then API Gateway routes your request to the backend. And this backend could be AWS Lambda or it can be any other backend services. And now the backend processes runs the required business logic, as I showed you in my previous Lambda tutorial. We had a Lambda which was performing an operation on DynamoDB. So consider that we performed a GET request from API Gateway. It invoked our Lambda, which is having our code, that is a backend service. It is going to process and it is going to return the response to the API Gateway. Finally, the API Gateway can transform and format the response if needed, for example, converting it to JSON and send it back to the client. So your API Gateway essentially acts as a bridge between your user and the backend system, handling all the heavy lifting like routing, validation, and response formatting. So if your Lambda function is going to fetch the data from DynamoDB, it in the last tutorial we saw that it printed the output, and that output was the return of the items as part of the list. So it can return that as JSON, and API Gateway can send that back to the client, and then client can process that accordingly on its source. Now, before we uh, deeper, sorry, let's go over a few key concepts that make an API gateway special. Now, the first concept is going to be resource. This represents a URL path in your API. For example, suppose I have created a user table, right? So apart from user table, I can have a product table, I can have a logistics table, different kinds of table. Now, when you're going to go ahead and set up the resources in your API gateway, you can have your URL path like slash users, slash product, or slash different ID that you have. You can create a resource over there. Next is the method. This corresponds to the HTTP like get, post, put, delete, or patch that I was talking about, which tells the API gateway what action to perform on the source. If it is going to be a get method, it is going to fetch the data for you. Post method, it is going to put the data, post the data for you. Put method, it is going to put the data. Delete means delete, or if you have to perform any patching, it is going to patch that. Then comes the integration. So this is the backend service that actually handles the request. So it can be a Lambda function, an HTTP endpoint, or even a mock integration for testing without a real backend. So when we are going to go ahead and create the API gateway, at that time, you are going to encounter each and every core concept that I'm talking about right now. So pay attention, because everything, we are going to create users, we are going to use get, then we are going to use Lambda over here for our invocation. Then comes the stage. A stage represents a deployment environment. So whenever you create an environment, there it is developer environment, test environment, or production environment. So each stage gets its own unique URL, making it easy to manage different environments. So while creating our API gateway, we are also going to do the same. We are going to create our environment as dev. Inside that, we are going to create users. So it has its own unique URL inside the dev environment. So together, these concepts define how API is structured, managed, and deployed inside an AWS API gateway. Now, let's look at different integration types available in Amazon API Gateway. We just spoke about Lambda, but the most common one is Lambda proxy integration. It passes the entire incoming request directly to your Lambda function, letting the functions handle everything, the request, logic, and response. It's simple and widely used in serverless applications. Next, we have custom integration, that is Lambda custom integration, which lets you transform the request or responses using mapping templates before it reaches the Lambda function or before the response is sent back. This gives you more control over the data format. Next is HTTP integration, where API gateway forwards requests to external HTTP endpoints, such as your own server or third-party APIs. So you can be the entry point, and behind you, you can have multiple vendors to whom you are going to forward it that, right? To whom you would be paying, or they would be part of your association, allowing seamless connectivity beyond AWS. And AWS service integration allows you to directly connect to other AWS services like DynamoDB, S3, or S3 or step functions without writing any custom code. Perfect for quick internal automations if you want to make any. And finally, the mock integration. This doesn't connect to any backend at all. It simply returns a static response useful for testing or front-end development before your backend is ready. So each integration types gives you flexibility depending on your use case, from fully serverless architectures to hybrid or external API connections, as we spoke a few minutes before. Then comes the stage, that is stages and deployment in API gateway, and they play a big role in version control and release management. So a stage represents an environment snapshot of your API. For example, dev, staging, or production. So each stage acts as an isolated environment for testing or live traffic. And every stage, its own unique URL. So this is the same dev, test, and production that we are talking about, and this is known as stages. Now, apart from stages, you also have to understand the deployment. So you have to pay attention over here. So this makes it easy to separate development, testing, and production environment, as we saw from the stages perspective. You can also use stage variables to configure different backend per stage. For instance, connecting your dev stage to dev Lambda functions and your prod stage to production Lambda function. So all from the same API configuration, right? So as I said, like in dev, you will point to different Lambda function. In production, you will point to different Lambda function. And API Gateway maintains deployment history. So if new deployment causes any issue, you can roll back to your previous stable version easily. And finally, canary deployments allow you to gradually shift traffic to new API versions, though that is the advanced part. So I won't speak much on it. Later on, you'll understand. So now let's go ahead and create our API, in which we are going to create a REST API. We are going to create our user path under dev, and then we are going to go ahead and set up the HTTP and connect to our Lambda that we created in our last tutorial for Lambda functions, which is going to perform the operation of fetching the data from DynamoDB. It is going to fetch the data. It is going to go ahead and send that data back to us. So let's jump to our console. Once we are on the console, you have to go ahead and search for API Gateway. Once you are in API Gateway, first thing you will have to do is you have to create an API. Now, while creating an API, there are multiple options: HTTP API, WebSocket API, REST API, and as I said, we are going to work on REST API. You have to click on build. Once you click on build, now you have four options. The first option is new API from scratch, then clone an existing API. So I had created one demo API to show you. When you click on clone existing API, it is going to give the list of the APIs that you have already created. So see, I have created demo API. That's why it is showing. If I click that, it is going to get the configurations from that API and it will clone it. And over here, you can give it a new name once you clone it. So you can copy an existing configuration end to end. Now, if you want, you can also import an API from Open API definition. Okay. Next, if you need any example APIs with API gateway with an example, you can see over here. So this is how the API, Open API, looks like. You can check it over here. Now, coming back to new API, we are going to go ahead and create Cloud Engineer demo underscore demo API. And we are going to keep it regional. You can also keep it as edge optimized and private. So for regional, it is deployed in the current AWS region. Edge optimized, if you are going to take, it is going to route to the nearest CloudFront point of presence, and private APIs are only accessible from the VPCs. So these are the differences between all three of them. Now go ahead and click on create API. Once you click on create API, it will take few seconds and you are here on the console. So on the console, as soon as we clicked on create API, you saw that first thing it is asking us to do is create resources. So we can go ahead and create a resource over here. We can say create resource. Over here, my resource name is going to be dev. Create. Under dev, I am going to create another resource that is going to be users. Create. So now my user is created under dev. Okay. So once our resource is created successfully, the next thing is we are going to go ahead and create a method. I click on create method, and first you will have to select the method that you want. So these are the list of methods. So what I would do, I will say get method. So this is going to get the method, get the details for me. In this, you have multiple options as we discussed in the PPT, like Lambda function, integration with an existing HTTP endpoint that we already have, mock for your front-end applications, other AWS services. If you want, click on AWS service and then select the region. It will show you the list of other AWS services in which you can add inside your method to perform any operation via API gateway, and VPC link for internal communication, that is a private communication. So we are going to go ahead and click on Lambda function. Once we click on Lambda function, we are going to select our existing Lambda that we created in our last tutorial. And over here, if you want, to use Lambda proxy integration, you can enable this option, and it is going to use the Lambda proxy integration too. Now, apart from that, you have method request settings where you can add authorization, you can add URL query strings, you can add HTTP request headers, and you can also add request body. So we are not going to add any of this. So I'm just going to minimize this. Once I minimize, then we are just going to go ahead and click on create method. Once I click on create method, it is going to go ahead and create our method, and it is going to show over here. So this is our method which has been created. I have not set any authorization. API key requirement is not also there. So these are the basics. So now inside our user, we have get, and you will see over here that we have a Lambda integration too, in the diagrammatic format that it is showing. So guys, when I created this association of Lambda, you should see what happens in the backend. So right now we have not done any changes to Lambda. The Lambda was previously created. So because of the API creation, I will show you how powerful the integration is. Now I will open that Lambda that we had associated. And after this association, you will see that, see on the left hand side, the association is made successfully, that you can see over here. That is via the API gateway. First thing. Now if I go to configuration and if I go to permissions, you can see that as part of resource-based policy, the API gateway is already added. So API gateway is been associated in a way so that it has now has the power to invoke this Lambda and get the response from this Lambda. So this is how in the backend it works when you associate it directly from Lambda, from console, or by using any other methods while you are creating the API gateway. Just wanted to give you a glimpse of what happens behind the scenes in terms of permission addition and removal. So I will just close this Lambda, and coming back, once our get method is created successfully, what we have to do next, we are almost done. We are just going to click on test, and over here I am going to go ahead and click on test. So I clicked on test, and guys, you can see our API gateway spoke with Lambda function. Lambda function went to DynamoDB, fetched all the data, and it has returned us the response body over here. And you can see all the three records of the DynamoDB table. And I will show you once again. If I go to DynamoDB, our DynamoDB is having tables. Under tables, we have user. So when I click on user, you will see that we have three records, 001, 002, and 003. Now I will take you back to API Gateway, and you will see that all these three records are available over here, 002, 001, and 003. That is how API Gateway became your front gate, where you just invoked the API and the API did the talking to your backend, and the backend did the work for you, and it gave you back the results. So as a user, you are just invoking the API, and this all things are happening in the backend. That is the beauty of API Gateway. Now let's understand the API Gateway pricing model. So for REST APIs, the cost is about $3.50 per million request up to first 333 million requests per month. Again, whenever you are going to take any final decisions, make sure you see the official documentation. This is as per my research. It keeps on changing. Okay, so just a disclaimer for you. Now for HTTP, which is a very simple and more cost efficient option, the price is just $1 compared to the REST API. REST API was $3.50. HTTP is $1 only. And standard AWS transfer charges also apply when responses are sent back to the client. So right now we got the response back also, right? So this client has got the response back. So transfer charges will also be applied in this kinds of event that we have performed. If you are new to AWS, there is a free tier where you get 1 million REST APIs calls per month for the first 12 months. Now it has been changed to 6 months. So it keeps on changing, as I said. Keep in mind the optional features such as API caching or custom domain names may add additional cost if you enable them. What are these options? If you go to the console, see over here, API and custom domain names. Let's open this. Oh, sorry, not API. It is going to be custom domain names and domain name association. So these are the ones which are going to add additional cost if you're going to enable that. So these names are the resources that connect a registered domain to your API. And you can also use a custom domain name to provide a more intuitive URL for your API callers who are going to call your API. And the other one is you can create or delete an access association between VPC endpoints and a private custom domain. If you're going to opt for it, the charges are different and that would be applicable. So overall, API Gateway follows a pay-as-you-go model. So you only pay for the request and features you actually use. Now, let's go through some important features and limitations of Amazon API Gateway that every developer should know. You are a developer, you should know. First, the request and response size limits. So API Gateway allows a maximum payload of 10 MB and has a timeout limit of 29 seconds. Even though Lambda can run up to 15 minutes, API Gateway itself will run out after 29 seconds. So next is throttling. By default, API Gateway supports up to 10,000 requests per second per region. This helps protect your backend from sudden traffic spikes or overload. You can also enable caching at API gateway level, which stores responses temporarily to reduce the number of backend calls, improving performance and saving costs, especially for frequent access data. Suppose right now I performed the get operation, it went back, the code ran, it gave you the return. But if this same data, same API has been triggered, same data is going to be returned, and if it is already cached, it is not going to invoke the Lambda. So you are saving cost of the Lambda invocation and Lambda talking to DynamoDB and sending back the data, which is the transfer of data. Three different types of cost you have saved in this journey if you are using caching over here. And cross origin resource sharing is built in, allowing your web application hosted on different domains to safely call your APIs. And finally, request validation. API Gateway can validate request parameters and body content before they ever reach your backend server. As I said before, that authentication is part of API Gateway. It checks whether it is a valid request or not, then and only then it sends it back to your backend server. So for that, you can go back over here to your API gateway. Let me close this, and you will have authorizers over here. So in this, you can create a authorizer where you can check those things while you are creating. You can also have a resource policy to narrow it down. There are many options in terms of using that, as well as you can, if you have created your Lambda, you can have usage plans also associated to, sorry, if you have created your API, you can have resource plans for your APIs also. But for creating that API usage plans, you will have to first create the API keys, then you have to associate that to the usage plan when you're offering it to your clients. So together, these features make API Gateway not just a router, but a powerful, secure, and performance-oriented gateway for your application. Now, when running your API in production, it's crucial to monitor their performance and follow best practices to keep them reliable and cost effective. So starting with Amazon CloudWatch matrices, they will let you monitor the key data like request count, latency, and uh, 400, 500 kinds of errors that you're going to get. What are these errors? I didn't show you, right? So let me take you to the gateway responses, and these are the list of responses that you get from your API. So these are the responses. See, you can also go ahead and click on this and you can edit those responses that you have. See, so this is what your gateway responses is. And if you have CloudWatch enabled, in CloudWatch, you can check this gateway responses, or you can perform any actions based on the event which has been logged as part of it. Okay. Now, next is enable access logs in API Gateway. These logs capture detailed information about each request and responses, which is extremely helpful for debugging and analyzing API usage patterns. Why we are not doing it right now? Because as I said, it is for production environment, not for test environment or dev environment that we have implemented. You can also set up CloudWatch alarms to alert whenever you have a spike or latency uh, for your APIs, or there can be any API throttling also. That's why it's recommended that you keep the CloudWatch matrices enabled and you have appropriate permissions for that accordingly. You can enable caching for frequent requested data to reduce backend calls, which is going to cut your cost and improve overall API performances. And finally, version your API using stages. So over here, we have used resources. Now you also have stages. You can use stages. Okay. Okay. So I think I will have to sign in again. Let me sign in. Okay, so I'm back. So as I said, once you have the resources created, if you want to do the versioning, you can go ahead and click on stages, create stage, and over here you can create the versioning that you want as part of uh, as part of the stage that you have. You can also enable the cache settings and throttling settings over here by using stages. So this is the advanced part that you would be using in your production environment. And following this best practices is going to help you run your API securely, efficiently, and reliably in production environment. And thank you for watching. I hope this session helped you clearly understand how Amazon API Gateway works and how to build secure, scalable APIs on AWS. If you found it useful, don't forget to like, share, and subscribe to my channel for more AWS tutorials. And see you in the next video.